In this video, I'm going to set you a few questions based on the position vector stuff that we just looked at. I want you to read the questions, pause the video, and have a crack at them, then come back and check your answers with the working I'm going to present here. Here you go. The first thing I want you to do is find the position vector joining each pair of points listed below. So the points A and B, the points C, D, and then the points E and F. And then the second one I want you to do is calculate two position vectors, P, Q, and RS, using these points here, and then tell me what the result tells you about the vectors. So, pause the video and have a crack. So the first one, position vectors for each of these points. Now remember, the position vector AB is given by B minus A. So the position vector of B, take away the position vector of A. And the position vector of B is the vector from the origin to this point. The position vector of A, again, is the position from the vector from the origin to this point. So in this case, my vector for A is given by 3, 1, and my vector for B is given by 8, 4. So I've got my two basic position vectors. I can now use them to calculate the position vector from A to B. So it's going to be the B minus the A. So in this case, it's 8, 4, take away the 3, 1. Now remember, when we do this, we do top take away the top, bottom take away the bottom. So in this case, it's 8 minus 3, 4 minus 1. Do both these calculations, and you get 5, 3. So that tells me to move between A and B. So move from A along to B. I go along 5, then up 3. Second one, I want the position vector from C to D, and in this case, that will be given by the position vector for D, take away the position vector for C. Again, same logic as the AB, it's the position vector going from the origin to the point C and the origin to the point D. So my position vector C can be given by 0, 6, and my position vector for D is given by 7, negative 2. You just look at where the point is in relation to the origin. So what that means then for my CD is 7, negative 2, take away the 0, 6. Again, same as before, two x parts, top take away each other, and then the two y parts, negative 2 take away 6, as the bottom part, and we just simplify. 7 minus 0 gives me 7, negative 2 take away 6 gives me negative 8. So I've got my answer there. Now the last one, E to F, that's the position vector I'm after now, but both of these are given as generic points, so MP for the E and ST for the F. Well, that doesn't change how we approach it. All we're going to get is an algebraic version of an answer rather than a numerical one, which we've got here. So again, we need our two position vectors E and F, because to go from E to F, the position vector here, we have to do the F take away the E. So the E position vector is given by MP, and the F position vector is given by ST. So now we substitute in, and we get our answer. So we do F, which is the ST, take away the E, which is given by the MP, and what we end up getting is the S take away the M, and then the T take away the P. Now we've no values to substitute in at this point, so we just leave it like that as our generic position vector. The second question was calculate the position vector P, Q, and RS from these points, and then look at what the result tells you about the vectors. So the position vector P to Q, same logic as before, it's given by Q minus P, and our position vector R to S is given by the S minus R position vectors. So I can write down the position vector for every single one of these, and I'm able to use it. So I know that my P is going to be given by the negative 2, negative 3. I know that my Q is going to be given by the 1, 3 vector. I know that my R is going to be given by the 6, 5 vector. And I know my S is going to be given by the 3, negative 1. So I've now got the 4 vectors I'll need. I can just substitute in and do them. So the P to Q is the Q take away the P. So it's 1, 3, take away the negative 2, negative 3. So that tells me 1 minus minus 2 and 3 minus minus 3. So 1 minus minus 2, 1 plus 2, that gives me 3. 3 minus minus 3, 3 plus 3, that gives me 6. So my position vector P to Q is given by 3, 6. Now we do the R to S one, and that's given by the S vector here, take away the R vector there. So in this case, that's 3, negative 1, take away the R, which is 6, 5. So 3 minus 6 on the top, negative 1, take away 5 on the bottom. That then gives me negative 3 and negative 6 there. Now that is the same as negative 1 times the 3, 6 vector. Now looking at the two of these, if you can imagine we plot the points, so P, Q, R and S. So I've got my P there, my Q, my R and my S. What that tells me is the PQ vector goes there, and my R to S vector looks like that as well, but it's in the negative direction, so it'll be down. What this tells me is that the two vectors are parallel. They've got the same base vector of 3, 6. They're just multiples of each other. So what I can then say is that P to Q and R to S are parallel. They're parallel vectors to each other that will go in this sort of system here. So because they've got this base of 3, 6 and 3, 6, they're both multiples of each other. Yeah, the multiple's negative 1, but they're still multiples. They are parallel vectors. They start off pointing in the same direction. Their size and direction is just slightly different.